All right, we are working our way up that ladder. We've made it to the rung of the integral of sine to the fourth power theta d theta. This is done analogously to the previous video on the cos to the fourth power theta d theta's integral. Now, if you're following along these videos, a recommendation of mine might be that maybe you watch one of these videos and then try to solve the other one on your own in an analogous fashion, because that'll give you some practice. It's your call, of course, but the idea here is to learn ultimately. So I think that's a great idea for learning. I'm going to do this one again, like I said, analogously to the previous one on the cos to the fourth power theta d theta. Let's recall some things that we will need. For example, sine of the angle sum formula would be sine of a plus b is sine of a cos b plus sine of b cos a. So in particular, if I have sine of theta plus theta, it's going to be sine of theta cos theta plus sine of theta cos theta. So that's really going to be 2 times the sine of theta cos theta. And so if you solve for the right hand side sine theta cos theta, you divide both sides by 2, you get sine of the double angle over 2. Okay? And like I said, analogous to the last video, we can write this as the integral of sine squared theta times sine squared theta d theta. And then we invoke our most famous of all trig identities, that is to say that the sum of sine squared theta plus cos squared theta is 1. So this I can write as the integral of sine squared theta times 1 minus cos squared theta d theta. And then I can distribute, so I get this is the integral of sine squared theta d theta minus the integral of, let me write this as sine theta cos theta, that entire product squared d theta. And now we know what that product is. We just did that up there. So I'm going to sub that in. So we get the integral of sine squared theta d theta minus the integral of sine of the double angle over 2, that entire thing being squared d theta. And then you can say that this is equal to the integral of sine squared theta d theta minus, of course, a half squared is a quarter, which comes out of the integral. So it's the integral of sine squared of 2 theta d theta. And here we do a u sub. So let u equal 2 theta. That means that du equals 2 d theta. That means that d theta is a half of du. And so we get the integral of sine squared theta d theta minus a quarter of the integral of sine squared u times, instead of d theta, we're going to put that in right over here. So times a half of du. And so we wind up with the integral of sine squared theta d theta minus a quarter times a half is an eighth integral of sine squared u du. Okay. Now we have already developed what the integral of sine squared theta d theta, or on the right, the integral of sine squared u du is. We've done actually 2 videos to show that, so I'm not going to rehash all of that, but we will now put in the results, okay? So this is equal to, so I'll say C video. Actually, I could even say C videos because I have 2 of those. All right, so the integral of sine squared theta d theta is equal to a half of theta minus a quarter sine of the double angle, and this is going to be minus an eighth, and here we go, that's the same idea except in terms of u, so it'll be a half of u minus a quarter of sine of the double angle 2u. And then I will go ahead and introduce a constant here, our favorite c hat, and then let's put in what u is, so we have everything in terms of theta. So this is going to equal a half of theta minus a quarter of sine of 2 theta minus an eighth of a half of u is, well, a half of 2 theta is just theta, minus a quarter of sine of 2u. 2u is 2 times 2 theta, that's 4 theta, plus c hat. And then this is going to equal a half of theta minus a quarter of sine of 2 theta minus, let's distribute now, minus an eighth of theta, minus times a minus is a plus, 1/8 times a quarter is 1/32 of sine 4 theta, minus an eighth of c hat, minus an eighth times c hat is, we'll just call that a positive constant c. Okay, so we're relabeling there. I can combine this term right here, the 1/2, with the minus an eighth, and that's going to give us the 3/8, just analogous to what we had in the last video. So let's go ahead and do that. So we get therefore the integral of sine to the 4th theta d theta is equal to a half theta minus an eighth theta is equal to 3/8 theta minus a quarter sine of 2 theta plus 1/32 of sine of 4 theta plus a constant of integration. And this formula is almost identical to the last one on the integral of cos to the 4th theta d theta. The only real difference, if you look between the two formula, is that minus sign right there on the quarter sine 2 theta. All right, that should do it for this one. We'll develop the integrals. Of course, you can guess what's coming next, the integrals of cos to the 5th and sine to the 5th, and then we'll look at the reduction formulas on these. Okay, see you in those videos.